So welcome everyone. Thanks for joining us. This is a quick webinar to dive into some interesting topics. I've got Gavin Hill with me here today. He's a senior team lead digital integrated manufacturing group at the AMRC. And what we're going to talk about is data-driven manufacturing. We're going to put it in the context of robotic finishing, and as you automate the hand finishing processes, how that can be a building block of a smart factory. But first of all, before we go too deep into anything, I'm going to kick it over to Gavin and ask him to tell us a little bit about what a smart factory is. Then we'll talk about how you transition into a robotic finishing system and what data sources become available to you, and then how you can approach that using that data, and then how we can use this to improve our processes and our conversations and our factory overall when you start to have this as a key building block. So Gavin, I'm going to kick it over to you and let you tell us a little bit about what a smart factory is.
Beautiful. Thanks, Mike. I'll take just 30 seconds just so people can understand that I'm not just some random Irish bloke who's speaking gibberish to them. There's a little bit of logic behind why I'm here and why we're talking about this. So at the AMRC, the Advanced Manufacturing Research Centre based in the UK, we do an awful lot of research into advanced manufacture, as you might guess. But my key area of expertise is really around the Industry 4 side and the digital elements that enable that. And we've been working heavily with AV&R over the last probably 5-6 years, really, to help refine some of these really innovative products in the space to support some of the key manufacturers that we work with in industries like aerospace and into the medical side as well. But when we're looking at what is a smart factory, so some people are lucky to have very deep pockets, and as a result, they can buy a new facility and it can have all the bells and whistles in the world. But for most of us, that's not reality. But that doesn't mean that the smart factory is inaccessible, because what happens is you start with a smart factory starting from what you already have. It is your facility. It is fundamentally still a factory, still a facility. And you couple that with the other things that you already have. Your smart people, your existing processes, your really tried and tested and well-proven machines. And you're essentially supplementing those with some of the really cool technologies that we've all been hearing about, we're all aware of. So things like robotics, like augmented and virtual reality headsets, looking at things like how artificial intelligence comes in there, or connectivity aspects like 5G. And it's about taking all of those isolated pieces of technology and making them more valuable by having that sum of the parts scenario. So if we're able to take all of those individual assets, all of those individual technologies, and bring them all together so that their data can be shared, we essentially are allowing ourselves to have a smarter facility. We're able to make better business decisions. We're able to work out if we could take on more work. We're able to work out why we've got an issue with the quality of a certain product, for example. And by implementing good practice within the smart factory space, we make sure that we've got a fully cyber secure facility so we can avoid, God forbid, some ransomware attack or something along those lines. It allows us to answer the questions that we probably didn't even know we had in our heads to start with, but we've got the information that enables that for us. And if we can't make those decisions, we can pass that on to some really smart systems like our artificial intelligence or machine learning algorithms to be able to give us insights into our business that we couldn't have got in any other way. And that really encompasses what the smart factory is. But I've got a couple of examples that go a little bit beyond just showing you a couple of icons in a slide that hopefully make a little bit more contextual sense. So if we look at the bottom left here, this is a composites braiding machine. And this is a machine that allows you to essentially have those two robotic arms holding a mandrel that allows you to move it forward, back, up, down, left, right, in a number of different axes, while at the same time wrapping different pieces of carbon fiber around it to create quite advanced structures. And there's a really smart control-based element in there with how those robots work together. But all of the logic that goes behind that and how you program that and how you feed that information back up to the rest of your facility and how you get information passed down to that device fits within that smart factory world. Up in the top right, this is a reflection yet again of we're not all going to buy the newest machine. We're not all going to have the newest assets. But some of those machines that we've had forever that are tried and tested can be brought into the smart factory world. So this is about legacy machine digitalization and putting sensors onto existing machines so that we have more of an understanding of how they're performing and how we can make better decisions. So by putting something like a current clamp onto an old lathe, we can get information about how many pieces are being made on that machine. We can understand how much it costs us to run that machine. And we can see how well utilized that machine is to say, could we take on a whole nother section of work, a whole nother order that we wouldn't have been able to work out without having those levels of intelligence put into the existing facility. Top left looks at how we accept and understand that we will not replace people. That's not the aim of the smart factory. The aim of the smart factory is to make us a better business. And a lot of the time, that's about making the people that we have be better at their jobs or have higher degrees of output, just having more enjoyable time. So up here, this is a smart workbench, and this is helping a person be more productive in their job by incorporating things like collaborative robotics or digital projection onto a workpiece so they can know where to put the next component, how that should come together, using a camera to verify that they have put that sub-assembly together in the way that they were setting out to, and incorporating things like smart tools that might automatically torque a bolt to the right torque for that part of the process. And then finally, down the bottom right-hand corner, we start looking at technologies that are quite similar to what we've discussed already, but allow us to talk a little bit more around the collaboration that we've had with AV&R over the last number of years, where we look at using systems that incorporate robotics, machine learning, and camera and vision technology to be able to categorize essentially how good or bad a part is, and to be able to use that information to feed back into our ongoing design cycles to make better parts in the future. So these are all good examples, but the final one that I've got for you is a little bit more visual. So in the video here, we've got an example of where you might have a robot, for example, and that robot needs to do something today, but it needs to do something else tomorrow. So usually you would have to reprogram that entire robot every day, and that's quite a tough and laborious task. And there's systems that make things a little bit easier, but could we make that easier again? So in this instance, we're using an augmented reality headset, and with that headset, we are in the virtual world planning the path of the robot. So we pick a point for it to go to, we hit plan, and then the virtual overlay moves to that position. And we can check while looking at that if it's managed to hit into something, if it's managed to take an odd turn, for example, or perhaps be in the way of a piece of fixturing. And then if we're happy, we just hit the execute button and we get the real robot to follow that path. And it means that we could, in a much more fast, accessible way, be able to update the program that our robot looks at. But hopefully that's given you a good idea of, a bit of interpretation of what the smart factory is in an accessible way. And from there, I'm going to pass back across to Mike, who's going to hopefully give a little bit more context on that.
Yeah, great. Thank you, Gavin. Excellent examples. So I'm going to talk a little bit about manual finishing. So, Gavin, you talked about some of putting sensors on some of the manual operations in older machines. Certainly in manual finishing, that's certainly an option. The process itself, for a person, it ends up being pretty labor intensive. It's repetitive, physically demanding. Often our customers are looking at, they've got complex or critical parts, high value parts to finish. So there's just beyond the data itself, there is a business case to looking at some automation. And, within a finishing process, you've got a lot of factors to control. There's many parameters and data, and time is limited. So, the other thing that I like to say is that moving to a smart factory, it's not about eliminating people. It's maybe more about changing their jobs or enabling them. And that's one of our visions as well, too, is giving tools to some of these finishers where they understand their parts, the process very well, and allowing them to bring it into first a digital environment and then put it on your shop floor. And that becomes a key building block of some of these small factories. So let me talk a little bit about first what are sources of data within some of these robotic finishing cells. Here's a little video kind of giving an overview of one of our BFX 200Cs. This is a collaborative video we did with 3M. We use a lot of their abrasives, and this type of system really optimizes the use of the abrasive. So you're going to have a much more efficient, you're going to use far fewer abrasives. At the center is a robot, but we can really consider this as an abrasive finishing machine, right? And once you start thinking about it like that, that starts to unlock different ideas, right? So behind me here, I'm sitting in front of a robotic system, abrasive machine. So we've got a number of sources of data that we can use, and we can end up gathering a lot of information about what's going on in this process. And that's important because you want a consistent process. So maybe you want to make sure you're running the same feeds and speeds and pressures. But then you also maybe want to capture what happened to that part during the process, right? So we've got a key sensor. This is for taking pre-process measurements or post-process measurements. A person is an adaptive. We look at something, we pick it up, we adjust. This allows the robot, the system to adjust. We've got a robot with a force feedback sensor on it, so that gives the robot a sense of touch. This robot, we control all the speeds. We monitor all the values of the motors, the torque values, the current values, so you understand, is this robot operating correctly? You got polished spindles, you've got belt systems, you've got AC motors. All of these are driven by drives, smart drives, which you can collect things like drive power, temperature, torque, voltage. So there's a lot of data coming back, right? So you got to be organized when you start thinking about this. If you don't jump into robotics, if you start without having an idea of what data is in mind, it can be a longer path to make use of some of this data. Here's how we think about it. Often the manufacturing process is serialized. So you produce, one widget, let's say this mouse, and you assign that a serial number. So as it goes through its process, you can track what happened to it. What program revisions did I use? So you can understand if there's any variations, you can start to pinpoint where those variations coming from, right? Then you've got your process recipe. And that's version controlled. So, when a person picks up a part, we look at it, maybe do something different, or between, let's say, myself and you, Gavin, we might try and achieve the same process, but we'll approach it two different ways, right? So with a robotic system, you could have 4 or 5 robotic systems all running version 3 of the program. So that's important to track. And then the real-time data, right? So all those different sensors and tools that I talked about, so all that comes back into a database and is structured so that you can mine that data later. Now, key thing to make this easy, because it's got to be easy. There's a few layers, the few layers in the stack of technology to build out one of these systems. So let me just log into my offline version of Brainwave. So this is what runs the machine, but we also offer this as a offline package. So you can imagine you have a production piece of equipment on the floor. If you're preparing it for the next generation of parts that are going through your facility, this greatly helps you and shortens the development times where your engineers can be sitting at their desk preparing all the recipes, programs, doing full simulation before interrupting your production and putting it on the shop floor. So this is what we're looking at here is the Learn page. We've got a number of different modules. So if we were on a system, all the maintenance is monitored. We have maintenance schedulers. We have all the alarms, the results, run page. I'm going to focus mostly on the learn page, and this is where everything comes back and all these parameters and control happen. So we'll take this part. This is a valve, part of a valve pack assembly, and we were deburring this part. So we split it into features, and each feature has one or more paths. Right? So I'm going to focus on this one right here. And so we have 3 paths, and each path is a number of points. Right? So I'll grab these 2 points, and on those 2 points we have our control parameters. Okay, so you can affect things like the acceleration of the robot at that point. You could do RPM. You could do force applied. So all the key parameters that you may want to control during the process. So if I want to modify this, I've got an RPM of 5,000. So let's make it, I'm going to greatly lower it. I'll put it at 30. I hit enter, and everything is very visual. So you quickly see what parameters I've modified. So all these other points are at 5,000. These 2 are at 3,000. I can go to my edit sequence. I can run this. And built into our software is the digital twin of the system. So right away, I can validate, is this process working the way I expected it? I can look up for any collisions. And is the robot able to reach all the points and stuff like that? So this greatly shortens development time. So all these parameters that I showed you, all this layer list, this is all brought back to centralized database. And then how can we use that? So a very quick example, and this would be for the decision makers, for the engineering managers or the production managers. The first thing you go through all you lean out your process, you do all your homework, you finally get this automation on your floor, you do your acceptance tests, and is this piece of equipment giving me what I want? Am I getting my bang for the buck? So this is OEE. This is a screen built right into the system, and it's essentially mining the data that you've been collecting, and it tells you overall equipment effectiveness. So I've got customers where the plant manager walks up and they do their daily walk around. They come up to this screen and they look, okay, how was I running on the day shift compared to the evening shift compared to the night shift? Now, in this particular example, they've got a few questions to ask because I've only got 26% availability. From an automation system, you should expect 90, 95% or better availability of that piece of equipment. And they can look at, start asking questions. Okay, what's going on here? How can we improve this? So it quickly gives them tools to have conversations on the floor and a quick snapshot of what's happening. Now, all this data can be brought back to the smart factory on your shop floor, right? So, when Gavin was talking about the big picture and tying everything back and looking holistically at all this equipment and giving people better tools to make decisions, now you've got this piece of equipment plugged in to your smart factory. You're gathering more data. You have a much more consistent process, and your finishing team, they've become the team to scale out, and put a number of these systems on your floor as you start to win more business. So as I promised, this is a very quick overview, a quick webinar, just to give everyone an introduction to Smart Factory, how robotic finishing can play into that. And Gavin, I really appreciate you coming on and giving us the big picture of what is a Smart Factory and why is it important to everybody.
An absolute pleasure. Thank you very much.
We are available now on the chat to answer any questions and to have a discussion about any topics you might want to go into. Thank you very much again, everyone.